All right, here's the screencast for section 6.5. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. All right, and do note that this means it can never be a parallelogram. It has exactly one pair of parallel sides. Parallelograms have two. All right. So it can never be a parallelogram. So the parallel sides are the bases. So here the two bases are AB and DC in this example. These are the bases. The non-parallel side are called the legs. And here the legs are AD and BC. So a trapezoid has two pairs of base angles. And the base angles, this is one set, angle D and angle C. And then we have another set of base angles, A and B. Angle A and angle B. All right, so that is the definition of a trapezoid. Has exactly one pair of parallel sides. So the two bases are the parallel sides. The sides that are not parallel are the legs. And the reason is because if I extend out the legs, notice they cross right here. That's where they cross. So they're not parallel because eventually if I extend out the sides, they will cross. All right, we have two pairs of base angles, right? We have the first pair of base angles and we have the second pair of base angles. Now, I just said that they're base angles. I didn't say anything about them being congruent. Now, a specific type of trapezoid is an isosceles trapezoid. We know from triangles what it means to be an isosceles triangle. An isosceles triangle has two sides that are congruent. So this side and this side would be congruent, and then these angles would be congruent. All right, this would be an isosceles triangle. So an isosceles trapezoid is similar in the sense that we have the legs are congruent. We have a pair of congruent legs. Just like a triangle had a pair of congruent legs, here in a trapezoid we can have a pair of congruent legs. Notice it's not the bases, it's the legs, the two sides that are non-parallel. If they're congruent, we call that an isosceles trapezoid. All right, recall from chapter 3, the same side interior angle theorem. We've been using that every single chapter since then. So if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. Okay, so what that means is, let's highlight this. So I have two parallel lines, and here we're cut by a transversal. So these two angles, 60 plus whatever this angle is, they have to be congruent because they are same side interior. All right, same side interior angles. So together they add up to 180. So if we take 180 minus 60, this angle must be 120. And then wait, we know, we can figure this out. We know the other angle as well. We can go through as well. Okay, so according to here, these two angles, this one and this one, should equal to 180 because they are also same side interior angles. All right, so if I take 180 minus 90, I get 90 degrees. So this is also a 90-degree angle right here. All right, so this just helps us solve angles. We know all together these must add to 360. In a quadrilateral, the sum of the angles is 360, and here it is 360. All right, EFGH is a trapezoid. Find the missing angle measures. Okay, so we know, okay, here are the two parallel sides. That means this transversal that goes through the two parallel sides, these angles must be supplementary. All right, these two angles must add up to 180 degrees. So if I take 180 and minus 90, I get H is 90 degrees. So this must be a 90-degree angle as well. So, all right, okay, in order to find angle F, there's two ways we can do it. We could add all of our angles and they should sum to 360, or I look and these two angles should add up to 180 as well. So I'm going to take 180 minus 50 and I get 130 degrees. So this angle right here is 130. So if you wanted to double check, we could take 90 plus 50 plus 130, and that's equal to 360. That's the sum of all of the angles in a quadrilateral. All right, so all four angles together add to 360. The two same side interior angles will add to 180. Notice it's not any two, it's not the base angles. Literally, it's because we have these two parallel lines that all have one set of parallel angles. I'm sorry, one set of supplementary angles and two sets, second set. So I am not highlighting the pair of base angles. It's literally the angles have to be touching different bases. All right, it has everything to do with the same side interior angle. So you can pause this video and give this next one a shot and then push play when you're ready. I'm gonna go ahead and continue on. So I have these two parallel lines. I highlight them. That way I see, okay, I have a transversal cutting, so that means these two angles must add to 180. So 180 minus 125 gives me 55 degrees. Let's see, is that right? 127, yep, 180, perfect. So angle H, 55 degrees. Okay, and then I look over here. This angle plus this angle together, they're same side. They're going to be supplementary. They will add to 180. So I take 180 minus 30 and I get 150 degrees. Okay, so placing is everything, right? These are same side interior angles. I'm not looking at the two angles next to each other. No, I'm looking at the two angles that are on the same, touching the same transversal, but different bases. All right, last part. So if trapezoid is isosceles, then each pair of base angles are congruent. So if we have an isosceles trapezoid, that means that both parts of the corresponding base angles will be congruent. So the two angles that touch the same base, they'll be congruent if we have an isosceles trapezoid, meaning the legs are congruent. All right, and then if a trapezoid has a pair of congruent base angles, so if we see that we have a pair of base angles that are congruent to each other, then we know that the sides will be congruent and it will be an isosceles trapezoid. All right, so here we have an isosceles trapezoid. Find the missing angle measures. Okay, so because an isosceles trapezoid, that means these two sides are congruent. I know it's those two sides because these are the parallel ones. The parallel ones are the bases, and the ones that are not parallel are the legs, and the legs would be congruent. Okay, so because it's an isosceles trapezoid, this angle must be 100 degrees because base angles are congruent. So angle C, 100 degrees. All right, let's see. We know that the consecutive, right, these two angles, C and B, have to add up to 180. They're same side interior. How do I know that? Well, here are my two parallel sides cut by a transversal. That means that these two same side interior angles will have to add to 180. Since they add to 180, I take 180 minus 100. I'm left with 80 degrees. So B is 80 degrees. But wait, if B is 80, that means A must be 80 because the theorem up above says if a trapezoid is isosceles, which we know it is, each pair of base angles are congruent. So D and C are congruent, A and B will be congruent. All right, last one of this screencast. Here we go. So we know this isosceles trapezoid. Once again, I see here are my two parallel sides. That means if an isosceles triangle, boom, boom, the two side lengths, same. These two angles must be the same. So C and D are both 70 degrees. Isosceles trapezoid means each pair of base angles are congruent. So C and D, base angles, they will be congruent to each other. All right, let's finish this up. So I know that these two angles are same side interior. They have to add up to 180. So if I take 180 minus 70, I get that this is 110. But wait, B has to be congruent because that's isosceles trapezoid, so they both are 110 degrees. Awesome. So that's it for the first half of this lesson. We will continue next class.